whole lot of shaking going on. In the last 36 hours, dozens of earthquakes have been recorded.
Helens is an active, explosive, regularly scheduled volcano. It's erupted more than any other in the continental U.S. over the past few centuries.
A red alert has been issued by geologists following escalating activity beneath one of the Cascade Volcanoes, sending ripples of concern across the Pacific Northwest. This development marks a critical moment in the close monitoring of one of the most seismically and volcanically active regions in North America. For years, experts have studied the volatile nature of the Cascade Range, a chain of volcanoes stretching from Northern California through Oregon and Washington into British Columbia. These giants, many of them capped with snow and cloaked in ancient forests, are beautiful yet unpredictable. Now, one of them appears to be waking up in earnest. Before we start, smash the like and subscribe buttons for more updates. The warning signs leading to the red alert were not sudden, but their acceleration has been swift and alarming. Over the past several weeks, geophysical instruments recorded a sharp increase in seismic swarms, clusters of small to moderate earthquakes concentrated beneath the volcano. These tremors, initially sporadic and shallow, have deepened and grown in intensity, hinting at the possible upward movement of magma. In addition to the seismic activity, ground deformation has become more pronounced. Satellites and GPS stations have documented a bulging of the Earth's crust near the summit and flanks of the volcano. These subtle but critical deformations suggest that molten rock is accumulating beneath the surface, exerting pressure and pushing the crust upward. Gas emissions, another key indicator of volcanic unrest, have also surged. Monitoring stations detected a sharp rise in sulfur dioxide and carbon dioxide levels around the volcano's crater and vents. This surge is a telltale sign of magma nearing the surface, as these gases are typically released when magma depressurizes and ascends. While the volcano has emitted small quantities of gas in the past, the current rate is significantly above normal and cannot be attributed to seasonal or meteorological changes. Taken together, seismicity, ground deformation, and gas output, these signs prompted geologists to elevate the alert level to red, the highest on the United States Geological Survey's scale. Red alerts are not issued lightly. They are reserved for situations where an eruption is imminent or already underway, and they signal the need for immediate public awareness and preparedness. This escalation shifts the conversation from scientific curiosity and long-term risk to immediate hazard and response. Authorities, emergency services, and local communities now face the daunting task of preparing for a potential eruption that could unfold at any moment. In this context, timing is everything. Volcanic systems are inherently unpredictable, but the signs point to a narrowing window before eruptive activity begins. The Cascade Volcanoes are products of the subduction zone off the Pacific coast, where the Juan de Fuca plate dives beneath the North American plate. This tectonic convergence fuels a subterranean cauldron of molten rock, slowly rising toward the surface over centuries. The most infamous eruption in this region was Mount St. Helens in 1980, which leveled forests, choked rivers with ash, and claimed lives despite weeks of warning signs. Since then, monitoring networks have expanded significantly. The current red alert benefits from these advancements, providing a far clearer picture of what may lie ahead. Yet, despite all the technology and analysis, nature retains the final say. A major eruption in the Cascade Range carries profound implications, not only for nearby towns and cities, but for the entire Pacific Northwest. Depending on the volcano's location and eruption style, the fallout could take multiple forms. Pyroclastic flows composed of scorching gas and rock fragments could cascade down the slopes at hundreds of miles per hour, obliterating everything in their path. Lahars, volcanic mud flows created when hot material melts snow and ice, could surge down river valleys, consuming bridges, highways, and entire communities in minutes. Even if the eruption is less explosive, lava flows could disrupt infrastructure, including power lines, pipelines, and communication networks. Ash poses another serious concern. A significant eruption could send plumes of volcanic ash miles into the atmosphere, where prevailing winds might carry it eastward across the continent. Fine ash particles can ground air traffic, clog engines, damage crops, and contaminate water supplies. Inhaling ash can also pose serious health risks, particularly for children, the elderly, and those with respiratory issues. Cities far from the volcano's base could still be blanketed in gray, disrupting daily life and slowing commerce. This was starkly demonstrated during the 1980 eruption of Mount St. Helens, when ash reached as far as the Midwest. Evacuation planning is underway in vulnerable communities. Emergency managers are coordinating with federal and state agencies to prepare routes, shelters, and communication protocols. Schools, hospitals, and nursing homes are being briefed on contingency plans, and residents are being urged to prepare go bags with essential supplies. The goal is to minimize confusion and delay in the event of a sudden evacuation order. This kind of logistical choreography is complex and relies heavily on real-time updates from scientists and geospatial analysts. Even with all preparations in place, the situation could evolve rapidly and chaotically once the eruption begins. The economic ramifications of a major eruption could be severe. The Cascade Range lies near key industrial and agricultural hubs. Transportation corridors like Interstate 5 and major rail lines run perilously close to the volcanoes. If those routes are cut off by lava, lahars, or ash, supply chains across the West Coast could be disrupted. Ports in cities such as Seattle and Portland might be affected by closures or rerouting, impacting global trade. Agriculture, particularly in valleys fed by volcanic soil, could suffer from ash contamination or water scarcity if river systems are clogged. Insurance claims could soar into the billions, and recovery efforts might span years. The human dimension of this crisis is equally compelling. For residents who have built their lives in the shadow of these volcanoes, the red alert is more than a scientific abstraction. It is a deeply personal reckoning with the risks of living amid natural beauty that doubles as latent danger. Communities now find themselves grappling with uncertainty, fear, and the prospect of leaving behind homes, businesses, and memories. For indigenous tribes who hold the mountains sacred, the impending eruption carries spiritual and cultural weight. These peaks are not just geological structures, they are living symbols of identity and tradition. The turmoil beneath the surface reverberates far beyond the physical landscape. Scientists remain at the epicenter of this unfolding story, working around the clock to interpret signals from the volcano. Every tremor, every gas reading, every satellite image is analyzed in a bid to predict what will happen next. Yet volcanoes do not follow scripts. They can accelerate suddenly or stall for days. An eruption could start with a thunderous explosion or a slow, creeping exhalation of lava. While models and historical comparisons help, each volcano has its own personality. The red alert reflects the highest level of concern but does not guarantee a specific outcome. It is a warning, not a prophecy. Among the technical community, this event is also a proving ground. It tests decades of research, investment, and interagency coordination. Monitoring stations, which dot the mountains and valleys, are now feeding torrents of data into sophisticated models. Drones and remote sensors are mapping changes in the crater. Artificial intelligence is even being used to analyze seismic patterns and predict potential eruptive behavior. The integration of these technologies demonstrates how far volcano science has come, but also how much more remains to be understood. Volcanoes still defy easy classification, and their complexity demands both humility and vigilance. Public engagement has become a critical aspect of the response. Scientists and officials are making daily media briefings, town hall meetings, and educational sessions to inform the public without inciting panic. Social media platforms are being used to dispel rumors and spread verified updates. In an era of misinformation, clear communication is essential. Officials are also working to ensure that vulnerable populations, including non-English speakers and those without access to digital media, receive timely warnings and instructions. The goal is to foster a sense of community readiness, not alarm. The psychological strain of living under a red alert is considerable. Anxiety rises with each new tremor, each plume of steam. Some residents may choose to leave preemptively, while others hold out, hoping the volcano will quiet down. Daily life is disrupted by uncertainty. Schools may close, businesses may shutter, and routines become tinged with tension. Pets, livestock, and essential services must be accounted for in any evacuation plan. For many, the wait is the hardest part, knowing something is coming, but not knowing exactly when or how. As the hours and days unfold under the shadow of this alert, the landscape remains deceptively tranquil. Trees sway gently, snow still crowns the summit, and the sky may be blue. Yet beneath that calm exterior, molten rock is gathering force, pressured by immense geological processes invisible to the eye. The calm before an eruption can be haunting. History reminds us that many catastrophic eruptions were preceded by moments of stillness. It is in these moments that geologists and communities alike must remain most alert. The broader implications of this volcanic unrest extend beyond the region. It offers a stark reminder that the Earth is alive and constantly reshaping itself. In a world where natural disasters seem to blur together, fires, floods, hurricanes, the threat of volcanic eruption introduces a different kind of hazard, one that combines long-term geological processes with sudden, devastating consequences. It calls attention to the need for preparedness, investment in science, and respect for the raw forces beneath our feet. This moment may ultimately pass without a major eruption, or it may mark the beginning of a profound geological event. Either way, it has galvanized attention and action. The red alert is not just a warning, it is a call to remain aware, to respect the power of nature, and to recognize that even the most majestic landscapes are shaped by forces that do not ask permission to erupt. As monitoring continues and preparations intensify, the world watches and waits, knowing that in the Cascade Range, the Earth is stirring. While the current red alert has captured the spotlight, it also brings attention to the complex dynamics and behaviors of volcanoes in the Cascade Range that are often overlooked in calmer times. The volcano now under highest scrutiny, though unnamed publicly to prevent premature panic, is not isolated in its activity. It belongs to a larger, interconnected geological system where magma chambers and fault lines intertwine beneath the crust, often influencing one another in unpredictable ways. The ongoing signs of unrest in this volcano may well have implications for nearby peaks as well. Monitoring one does not mean ignoring the others. In fact, shifts in activity at one site can sometimes foreshadow broader patterns within the range. Beneath the surface, volcanic systems are not neatly confined. Magma can travel along fissures or exploit existing weaknesses in the crust, which means an eruption might not emerge from the central crater alone. There is always the possibility of new vents opening along the flanks or even miles from the main cone. This makes accurate forecasting especially challenging, since eruptive material might bypass familiar outlets entirely. For emergency planners, this scenario demands not only attention to topography, but an appreciation of how quickly hazard zones can expand. As the volcano inches closer to a potential eruption, scientific teams have started deploying mobile instrumentation. These portable stations, including seismometers, spectrometers, and infrared cameras, allow for granular observation of specific hot zones where activity is most concentrated. Helicopters and aircraft equipped with thermal imaging have flown repeated passes, capturing snapshots of evolving heat signatures. These high-resolution images often reveal subtle cracks, vents, or fresh flows invisible to the human eye from ground level. Through this, scientists aim to pinpoint exactly where magma might breach the surface and how it will behave once it does. One of the lesser-known aspects of preparing for a volcanic eruption involves analyzing the type and composition of the magma involved. Not all magma is created equal. Basaltic magma, for instance, tends to produce gentler eruptions with flowing lava, while rhyolitic or andesitic magma, more common in the Cascades, is more viscous and gas-rich, prone to explosive eruptions. Preliminary petrological studies of recent gas samples suggest the magma involved in this current episode is rich in volatiles, including water vapor and sulfur compounds. That raises the likelihood of an explosive scenario rather than a slow effusion of lava. This possibility of an explosive eruption also places significant pressure on aviation authorities. Volcanic ash is among the most dangerous hazards to aircraft, capable of clogging jet engines and sandblasting cockpit windshields. The Federal Aviation Administration and international aviation bodies have already issued preliminary notices to reroute or limit flights over the region. In previous eruptions worldwide, such as the 2010 Eyjafjallajökull eruption in Iceland, air travel was halted across continents. The Cascade Range, with its proximity to major airports like Seattle, Tacoma, and Portland International, could create similar disruptions if ash clouds enter flight paths. While much focus is placed on ash and lava, another critical threat looms from the glaciers and snowpack that blanket the upper elevations of these volcanoes. A sudden eruption can rapidly melt these frozen reserves, sending torrents of water mixed with ash and debris crashing downhill, creating lahars. These deadly flows can travel at highway speeds, burying valleys and cutting off escape routes. Historically, lahars have traveled tens of miles from their source, destroying bridges, railways, and entire towns. The presence of significant snowpack on this volcano amplifies that risk considerably, especially during the warmer summer season when melting accelerates. Downstream of the volcano, river systems are already being evaluated for their potential to funnel and amplify the effects of lahars and flooding. Sediment loading in these rivers could alter flow patterns, raise flood risk, and impact water quality for cities that depend on them. Engineers and hydrologists are now working to simulate worst-case scenarios based on topography, water volume, and slope gradient. This modeling feeds into real-time alerts that could save lives if flows begin cascading down the slopes during or immediately after an eruption. For the power grid, the red alert raises questions of resilience and continuity. Ashfall on power lines can lead to insulator flashovers, where ash becomes a conductive pathway during wet conditions, causing short circuits or even fires. Hydroelectric dams, which many parts of the Pacific Northwest rely on, could face inflow surges from glacial melt or lahars, putting pressure on their spillways and raising the possibility of overtopping. Engineers are on alert to adjust reservoir levels and assess vulnerabilities in dam structures that could be exposed to large sediment inflows. The communications infrastructure, too, is under examination. Cell towers in elevated locations are susceptible to both ash damage and seismic disruption. Redundant networks, satellite phones, and emergency broadcasting systems are being prepared in case main channels fail. Rural communities especially could become isolated if roads and lines of communication are severed. Coordination among agencies from federal to local is being stress tested in drills and simulations designed to account for multiple contingencies. Local industries are already feeling the strain of anticipation. Tourism, which fuels many towns near the volcano, has come to a standstill. National parks and hiking trails have closed, and recreational permits have been suspended indefinitely. Campgrounds have emptied as rangers evacuate visitors and prepare for fire risk or falling ash. Lodges, small shops, and seasonal tour operators are bracing for economic losses that could linger well beyond the eruption's peak. Insurance coverage for volcanic disruption is often complex and uneven, leaving many businesses in legal limbo. The agricultural sector faces unique and immediate threats. Fine ash particles can coat crops, reducing photosynthesis and damaging plant tissues. Dairy and livestock operations are making arrangements to shelter animals indoors, provide clean water, and stockpile feed. Farm machinery may also suffer, as ash can infiltrate engines and gears, leading to mechanical failure. Fields left uncovered may not be viable for planting until ash is cleared, a process that can take months depending on thickness and weather conditions. Schools and educational institutions in the area have pivoted swiftly. Many have transitioned to remote learning in anticipation of ashfall and poor air quality. Teachers and staff have received training on how to manage students during an evacuation or shelter-in-place order. Some facilities are being converted into temporary shelters supplied with food, bedding, and medical kits. Universities with volcanology departments have turned their attention inward, offering public lectures, quanda sessions, and live-streamed updates to help bridge the gap between scientific insight and public understanding. Culturally, the volcano's awakening has stirred deep-rooted narratives and folklore among native tribes who have long inhabited the land. Many of these communities view volcanic events not only through the lens of geology, but also through spirituality and ancestry. Ceremonies have been held in private, honoring the mountain and seeking balance between humanity and the Earth's forces. Tribal councils have engaged closely with scientists and emergency planners to ensure that evacuation orders, if issued, are both respectful and timely, with cultural artifacts and sacred sites given due consideration. Scientific collaborations are expanding as researchers from around the world converge on the area, virtually or physically, to assist in monitoring and analysis. Volcanologists from South America, Japan, and Europe are offering comparative studies from their own experiences with similar volcanoes. Data sharing platforms are running 24/7, allowing for rapid peer review of findings and predictions. The event has become a living laboratory, an unprecedented opportunity to study the full arc of volcanic awakening with modern tools and global expertise. This red alert scenario also provides an urgent reminder of how vital public policy is in disaster resilience. Investment in early warning systems, land use planning, and emergency education are paying dividends now. Communities that once might have been caught off guard are better positioned today because of years of effort in public safety campaigns. Still, the alert also exposes gaps, places where evacuation routes are too narrow, or where population growth has brought people into high-risk zones once considered safe. The psychological dimensions of volcanic crises are often underappreciated. Mental health professionals are beginning to mobilize, preparing to support those affected not just by physical loss, but by the prolonged anxiety and displacement that such an event entails. Volcanic activity doesn't just destroy landscapes, it erodes a sense of stability and normalcy. For children, the disruption can be particularly traumatic. Parents, educators, and counselors are already reporting spikes in stress-related behavior, insomnia, and emotional distress. Addressing these needs will require sustained attention long after the last plume of ash has faded. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the Cascade Volcanoes alert? Will an eruption happen soon? We want to hear from you. Thank you for watching and see you next time.